can you see a worksheet?
Yeah, I can see.
Yeah, can you tell me roughly what do you see there, just to make sure?
I can see.
Can. Okay, what do you see on the worksheet?
The series circuit.
Okay, very good. Right, so this is the series and parallel circuit thing that later on I want to go through again. Okay, I'll go through this again with you. Wait, give me a minute. Okay. Okay, can. So over here you can see this series and parallel. Remember yesterday we actually went through the electricity formulas, right? Do you remember what are the electricity formulas that we went through? Just the electricity part.
The three pyramid thing, right?
Yeah, the three pyramid thing. I'm gonna draw on the board, right? This E, P, T. Oops. Wait a minute. Okay, E, P, T, I, V, I, R. Okay, so this is a triple pyramid. Can you see the triple pyramid thing over there?
Yeah, I can see.
Okay, so can you?
I can see.
Great. So the screen, everything is fine, right? Is it okay? Okay, so can you tell me the SI unit for each of them?
And the SI?
Yeah.
The top one is energy, right?
Yeah, the first one is energy. Then P is. What is P?
Power.
P is power, so it's in terms of watts. How about T?
Seconds.
Yeah, T is time. Second, I is
Current.
then V.
V is voltage.
Voltage and the I and the R is current and resistance again.
Resistance.
Okay, very good. So this is the first thing, the one that we are looking at right now over here. There's three formulas that you definitely need to know. Then there is some others that you need to know, which is shown over here. This is a series circuit. Okay, now this is a series circuit. So what is the meaning of series? That means the whole thing. Can you see that the car? Yeah. What's the meaning of series?
Series is like everything in one path lah.
Yeah, very good. Right. So can you see that the current is just going in one direction?
Yeah.
Alright, it's going in one direction. So at any point of time, the current doesn't have to split. So that's called series. Okay. Now for series, the current, right? They are all the same. They are all the same. Meaning, you see, I1. Can you see this formula? I1 equals to I2 equals to I3.
Yeah, I can see.
But do you remember the formula that I1 equal to I2 equal to I3?
The I equal to what?
I1, the effective, look at this one. Effective current is equals to I1 equal to I2 equal to I3.
Oh yeah.
Yeah. Okay.
I see.
Yeah, do you remember this? Because I need you to remember this one. This one must memorize. Is it okay? Must memorize this, Okay, next one is voltage.
Yeah, it's okay.
Yeah, so voltage, the voltage, right, is V1 plus V2 plus V3. So do you see what's the difference between the current and the voltage? The top one, current is equal. They're all equal, but the bottom one is plus. Correct? Yeah, you can see the voltage, right, is plus. Now what does it mean? That means if you look at this whole diagram here, the V1 plus V2 plus V3 is equal to the EMF, which is at the top. So for example, if I have a battery that is 3 volts, okay, can you see the 3 volts written?
Yeah, I can see.
So if the EMF is 3 volt, right? So each one will be 1 volt plus 1 volt plus 1 volt, because add together equals to 3. Okay, this one can. Okay, next is the resistance. So the resistance is the same as the voltage. So it's R1 plus R2 plus R3. So we can actually summarize this. Let me write down on the other side. So for series we have the current, the voltage and resistance. So R T equals to R1 plus R2 plus R3. Then voltage is V is equals to V1 plus V2 plus V3. And last one, I equals I1 equals I2 equals I3. Okay, so that is the summary for series. Then the next thing, of course, you need to know is parallel. Okay, so what do we do for parallel? So for parallel, the formulas are here. Okay, so before we look at the formula, right, do you know what are the formulas for parallel? Let's say for current, voltage and resistance.
Not sure.
This one must know, right? So if you are not sure, that's why it's difficult to do. So I equals to I1 plus I2 plus I3. Then for voltage, V equals to V equals to V1 equal V2 equal V3, and the last one 1 over RT 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so here altogether we have now 6 more formulas. This whole thing is 6 formulas. Alright, so you know what this means? This means altogether for physics, electricity, there's 9 formulas. Why 9 formulas? Because there's 3 here, 3 of them here, EPTIVIR, that's 3, and then we have 6 over here. 6. Is that okay? Can? Alright, so now actually I need you to be able to remember this one. You need to be able to remember this, the series and parallel. Is it okay? Because why? Now let me explain later. For today, we'll be doing let me explain. For today, we'll just do about 1 hour because I need to leave at 8. We will just do electricity. Okay? We make sure we try to do the electricity part for today. And after going through the formulas, I have the 10-year series questions. Can you see the 10-year series questions? They are at the bottom here. Okay, so I can go through those with you. Is that alright? Okay, so now I need you to do a little bit of work, right? I need you to try and remember these 9. That means 6 over here and 3 over here. Yeah, can you remember this? Can you see the worksheet now?
Yeah, I can see.
Okay, that's great. So okay, what I'm going to do is I'm going to go through all these electricity questions, right? These are actually from the 10-year series.
Oh, okay.
Okay, 10-year series, because the strategy right now, we don't have a lot of time. What you need to do is to be able to do the 10-year series quickly. Okay, so the fastest way for you to be able to do it is for me to go through as much as possible, and then after that I will explain to you which formulas that we are using, and you try and see whether you can follow. As we are going through this, if you have any questions, just let me know. Is it okay? Okay, great. So first one, now this is electricity and magnetism. So let's take a look at this. So the diagram shows 4 copper wire. Which wire has the least resistance? We are looking for the least resistance. Now the one with the least resistance is the one that is shortest. Okay, and
thicker.
Very good. Thicker, the thicker one. Now so which one do you think is the one that has got B? Yeah, so it's short and big. Okay, very good, that's correct.
Can I ask?
Sure.
Can I ask, like, what is the resistance like lower when it's thicker?
Okay, very good question. So let's draw two diameters. You see on the screen, so on the screen I have one on the left that is bigger, and then the one on the right is narrow. So the one on the left, because it's thicker, right, it allows more electrons to pass through. Electron can pass through, but the one on the right, only like one electron can pass through. So which one has a example? Just one example. You see the one on the left, we allow a lot to pass through. Correct? Okay. Can you see? Okay. Wait. So you see the one on the left, we see more electron can pass through, right? But the one on the right only allow one. So let's say imagine water is flowing. Okay, which one allows more water to pass through? Faster.
Faster?
Mm.
The thick one?
Yeah. Is it the left one or the right?
The left one.
Yeah, the one on the left allows more water to pass through. How come? Because it's bigger, the diameter is bigger. So when it's bigger, that means there is less resistance.
Because like there will be more electricity passing through.
Yes,
is it?
yes. At any point, there's more electricity that can pass through.
Oh.
It's like water. You know water flow. Have you watered plants before?
Yeah.
Have you used a big hose versus a small hose?
I always use a small hose.
Yeah, okay, next time you use a big hose, right? If you use a big hose, more water can pass through, right?
Yeah.
But if you use a small hose, the water cannot pass through so quickly. So more resistance. So this one will have more resistance. Okay, that's the idea. This one will have more resistance because water cannot pass through so quickly. Okay?
Oh.
Yeah, so use that idea. Okay? Alright, any other question? Feel free to ask me a question, right? It's okay. I think it's good.
No.
Okay, so we continue. So next one, what does a voltmeter measure? So we know voltmeter measure voltage. Correct? But over here, we never see any voltage. But you need to know that potential difference is also referring to voltage. Okay?
Oh.
Same as EMF. Oh, sorry, can you still see?
Yeah, I can see.
Okay, same as EMF. Can you see the screen?
Yeah, I can see.
Okay, because just now I got a message.
Oh.
Error message. Okay, so question number 3. Can you see question number 3?
Yeah, I can see the top only.
You can see the top only. Okay, something wrong already, the sky. Wait, give me a minute.
Okay.
The sky just now show error. Okay, wait, let me off and on again, okay? I switch off first. Okay, I know why. Because it only allows 30 minutes. Screen share only 30 minutes. So every time it will hang after a while. Alright, so we need to restart every 30 minutes. Okay, let me screen share one more time.
Nice.
Okay, start. Okay, wait, go to here. Okay, can you see the screen?
Yeah, I can see.
Alright, so we look at question number 3. So a cell has 1.5 volt marked on it. What does it mean? So we know 1.5 volt is voltage. So this is about voltage. So is it the current? No, right? Is it
No.
energy? Is it power? None of this, right? Because EMF. So answer is B. Because voltage is also V equal EMF is also potential difference. Can?
EMF is the
Motive force.
electromagnetic. Huh?
Electromotive force.
Oh.
Yeah, it's it's not electromagnetic force.
Oh.
Yeah, so there's a difference. Okay, next one. So it's the same thing. Which piece of copper wire has the greatest electrical resistance? So remember, can you tell me which one is it? Give it a try.
The longer one and the
Narrow.
thinner one.
Yeah, longer.
So answer C.
Wait, answer is C. C. Long and thin. Okay, very good. Next. Okay, for same stuff lah, right? You see, okay, the thing about this N level is that they repeat a lot of things So yeah, so this one no need to do already. Let's go. Okay, so now look at this one. In order to do this, should the student use an ammeter or voltmeter in which position? So what you need to know is that ammeter must put in series. Okay, voltmeter must put in parallel.
Oh, why?
Why? Okay, because now remember, what does ammeter measure? What does ammeter measure? Current.
Current.
Current. What does voltmeter measure? Voltage.
Voltage.
Correct. So how? Okay, what is current? Current is how fast the thing flow. Like how fast the electric current flow. So if you want to measure how fast electric current flow, it has to be in series. So for example, if you look at the diagram, right, we want to measure how fast the current flow, right? The flow of the thing, you must put here, so this must be ammeter. Okay, X must be ammeter and Y must be voltmeter. Okay, voltmeter, you are measuring potential difference. So potential difference is between one point and another point. So that's PD, potential difference. Okay, or if you want, you can just remember series, right? Always, for the ammeter, it's always in series, and voltmeter must always parallel. Okay, can? So with that, we actually have the answer. Okay, so the ammeter is X, right?
Yeah.
Then the voltmeter is Y. Okay.
Yeah.
Next one. So we have a voltage and current rating for 4 electrical. Which heater has the least resistance? This is where our formula come in. Remember, can you tell me what's the triple triangle formula that you need to know? E P
T
I V I R, right? Okay, so over here, what am I supposed to find? I need to find resistance. That means I need to find R. So to find R, what do I do? Voltage.
Take voltage times.
No, divide.
But voltage divide by.
Yes, voltage divided by current. So that means you must take this divide by this. Okay, and you want to find the smallest R. So you gotta take your calculator. Do you have a calculator with you?
I could take.
Okay. So I have let's do 22. 10 divided by 10 is 11. 4. 23. Okay, so which one has the smallest?
The smallest resistance.
Yep. 4 lah. C lor.
C.
Yeah. Wrong. Calculation error. 230 divided by 5 is 57. Wrong.
Then B.
Okay, B. Okay. Right. It's pretty simple. Next. Okay, what's the EMF? This one you must know already.
Volt.
Yes.
Measure volt.
Yes. Next. Okay, dry cell 1.5 volt. What does it mean? EMF. Okay, you see?
EMF.
Very fast one, repetitive. Next,
Yeah.
a student measure potential difference. Okay, potential difference means voltage, right?
Voltage.
And the current is the ampere. Which calculation gives the R? So using our EBT.
Voltage divided by current.
Yeah, V over R. This one. So you want to find R, V divided by R. Sorry, V divided by I.
Potential difference divided by current.
Yeah, so answer is C.
Yeah.
Okay, next one. Which arrow show the direction of conventional and the direction of electron flow? Okay, this is a bit confusing. What's the difference between conventional current and electron flow? Electron flow come out from minus. Okay, conventional current is here.
Also, convection current is plus, then electron flow is minus of the battery.
Yes. So you just find out which one. What? Direction of conventional flow P. Conventional P. Then electron flow Q. A, no? Okay? So 12, repeat. You see 12? Repeat again. Greatest resistance.
C.
C. Greatest resistance. Yep, that's right. Next one. Okay, same thing. Which one is minus? Minus is here. So electron flow here. Conventional current here. That means the answer is
it
B.
Is it
B.
B?
Yeah. Okay, do you know why?
Why?
Because you see, conventional current is this one. So it go this direction, ma. Then the electron flow is this direction, ma. Yeah. So there's a missing thing, This is electron flow. Alright. Okay. Next, repeat again. Don't want to do already. Skip. Which statement describes the movement of electron? Now we have a circuit.
Electrons is
here. Come out from here, right side.
Electron.
Yeah. So electron, what happens is this is a parallel circuit. When they come here, they will split into two parts. One here and go down here. Okay. Then when they come back here, they will join back. These two will join back and go back. So which statement describes the movement of electrons? A cannot be. They say the electrons are stationary. That's false. Electron flow from X to Y. This is false. Flow from Y to X. This is correct. So answer is C. Can?
What stationary is?
That means
doesn't move at all. Right?
Cannot be. Electrons moving on, ma.
Okay.
Wait a minute. Oh, wait. Okay, because the switch is closed. Right, this shows open. But now they say that they close the switch. So the answer is C. If the switch is open,
then the
stationary.
electrons are stationary.
Yeah, correct. Next. Let's go. We got a lot of questions to do. Okay, which graph shows how the current varies with voltage? Now, current versus voltage. Our formula EPTIVIR, right? That's the formula. So current and voltage is here. That means when voltage increase, when V go up, I also go up. You know why? So it's like if you use a very powerful battery, the current will be very strong, Does it make sense? Correct? That means
Yeah.
the answer is A. Because A shows that when V increase, yeah.
They say like the resistance does not change.
Yeah, so R remains. Sorry?
It doesn't mean. They say like the resistance does not change.
Yeah.
Why is it not like D?
B. This one?
Yeah.
This one cannot be because if it's D, what does it show? It shows that let's say I is 10, alright? Let's say I is 10. Then my voltage keep changing, right? 5,
Yeah.
then here is 10. My R keeps changing, right? In this case. You see here, if I take 5 divided by 10, I get half. 10 divided by 10, I get 1. The R keep changing. So cannot be D.
But then what about B? B is also.
B cannot. You see, what is R? R is equal to V over I. Correct?
Yeah.
R equal V over I. So when you take V divided by I, you are actually finding the gradient. So gradient never change. What is the meaning of gradient never change? This one gradient never change. I see a lot of hidden meaning one, right?
So it means that the resistance doesn't change lah.
Yeah, that means the gradient is the same. Okay. Alright, next one. Okay, conventional this one don't do already. Let me jump some questions, right? I want to do some difficult one. Some calculation. Okay, here's one example. Okay, so if a diagram shows two similar let me see, the heater is switched on. Okay, so a charge of 240 coulomb pass through the heater in 1 minute. What current flows in the heater? Now remember we have E, P, T, I, V, I, R. So apart from that, there's one more formula. Charge I equal to Q over
QOT.
So now they want to find current. Current means we gotta use this formula. Right? So we have to take Q, which is 240 divided by time. Well, time is 1 minute. 1 minute is 60 seconds. Right? So 240 divided by 60.
Charge is coulombs.
Yeah.
Okay. No.
Charge is coulomb. Charge is coulomb. Okay, this one, the Q is charge. Right? I is ampere. So to find the current, the answer is 4 ampere. So you need to know the formula. I equal Q over T. Okay? Next one. Can we continue? Any other question?
No.
Okay, so we move on. As we go along, you got any question, just feel free to stop me, alright?
Okay.
Don't worry. So what's the resistance of the heater? So we look at our formula again. R equal to V over I. So R equals to V over I. So V is here 250 divided by I is here 4. So we take calculator. 250 divided by 4. So it's 62.5 ohm. Right, so can you see how useful our formula is?
Yeah.
You gotta remember. You don't remember, cannot. You see the next one, what's the power output? Now, offhand, can you remember what's the formula for power?
Current times voltage.
So actually, to tell you the truth, I don't remember one. I just remember the formula. Right, I will refer back to this and then I say, where's power? So power is here. Right, so power means I take current time voltage. Yeah, that's how I remember the formula. So I gotta find Okay, so power equals to current times voltage. So what is my current? 4 ampere, right? And my voltage 250 volt. So multiply together 250 times 4. 1000. And what's the SI unit? Watts. So it's 1000 watts.
For this kind of question now, we can like use the answer for we get 250 volts from question B. We can just like take it from there, right?
Yeah.
Instead of like calculating it out.
Yeah, no need. Because it's one fixed question, what? It's one whole question. They're all related one. This question one, so the whole thing related.
Oh.
Yeah, right. So you gotta use them, okay? Okay, is it okay?
Okay.
So this one quite easy, yeah. So let's continue. Okay, this one I'm gonna skip. I want to look at some more calculations first, right? Jump. Okay, this is another one.
What is DC circuit?
Series parallel.
What is DC circuit?
Over here, you need to calculate direct current. So it's you gotta find series parallel.
So direct current means series?
Not really. Actually, you don't need to care about this one. This one don't care. Don't bother. Right? Just that this chapter is your series and parallel calculation. So just now the previous chapter was EPT IBIR, right? So now over here you have the series and parallel that you need to calculate. Okay, I want to jump because we left with about 15 minutes. I want to jump to some other questions that will show some calculations. Okay. Okay, this one. Okay, let's take a look at this particular question. Can you see the question? Yeah. Okay. So do you know how to do this one?
Wait. Not sure.
Okay, never mind. So I'll do it. So in which position M1 or M2 is a voltmeter connected? So M1 is series, right? Because it's within the circuit.
Yeah.
This one is parallel. Remember, voltmeter.
Why is it?
Why is it parallel? Is it?
I mean like why is M1 series and why is M2 parallel?
Okay, because M1 is in the flow. You see, this is the flow of the current. You see the blue color? Yeah. The current flow this way.
Yeah.
Ooh, so it's like water flow. The current flow here and go back. You see that? The blue color is the current flow. Oops. Okay, so the current flow. Oh, wait. Oh, sorry. Wait, my line is gone. Okay, wait. I'm trying to figure out what happened to my line. Oops. No lines. Okay, can back. Okay, so can you see that the blue color highlighted part is like the current flow. So M1 is directly inside the flow. This M1 is inside the flow.
Inside
the flow. See the blue color thing? That's where the current will flow. So M1 is inside the flow of electron.
But why does like the electron flow doesn't like go through M2?
Yeah, it does. It also go through here, but because voltmeter, okay, so for example, right, you look at this M1, okay, you look at M1, M1, is it series or parallel? When you look at M1, can it be parallel? M1? It cannot be parallel because the current flow this way mah. I know some of the current flow here as well. So the current flow this way, it flows here. So this thing is like directly inside the flow. So it can catch the current. It's like you know, imagine here got one fish. Draw a fish. Can you see a fish?
Yeah.
Imagine the electron is fish, right? So where will the fish swim?
Through M1.
Yeah, you swim through M1 what? So it's series. Why? Because M1 is like a net. It can catch the fish. Is it okay? Wait
Okay.
So I know your question is, but some fish also pass through here, right?
Yeah.
The fish also pass through here, right? Okay, but the voltmeter, this M2 is parallel to this part. The M2 is parallel to the battery, but M1 is series to the battery. Yeah, wait a minute. Okay, never mind. Let's just continue. We continue first, right? Later maybe we'll see some other examples and I can explain again how it works.
Okay.
Okay. So actually the answer is M2. So M2 because this one is parallel. So the next question is, how are the 2 and 4 ohm resistors connected? So here and
wait.
yeah.
I thought voltmeter is to measure parallel.
Yeah, correct. So M2 is parallel.
Okay,
M2 is parallel. M1 is series. Okay, so how are the 2 and the 4 ohm resistor connected? So these two is parallel. Is it okay?
Okay.
Yeah, so calculate the combined resistance of 2 and 4 ohm resistor. So because they are parallel, do you know which formula to use?
1 over
R. Very good. 1 over RT equals to 1 over 2 plus 1 over 4. Correct?
Okay.
Then you find common denominator. Wait, So 2 over 4 plus 1 over 4 equals 3 over 4. So this is 1 over RT. So if you want to find RT equals to 4 over 3, which is 1 and 1/3 ohm. Okay, so the answer is 1 and 1/3. Is that okay?
Okay.
Yeah, so next, find the total resistance of all 3 resistors in the circuit. This is the part where you need to use your 6 formulas. Okay, so just now we calculated this part, it's 1 and 1/3 ohm, right? We combine. But how about between 3 ohm and 1 and 1/3? Is it series or parallel?
Parallel.
Series. Yeah, series. So series, which formula do you use?
For resistance.
Yes.
Plus.
Yeah, you plus. So to find the total resistance, 3 ohm plus 1 and 1/3 ohm. So that is 4 and 1/3 ohm. So total resistance 4 and 1/3. Yeah, that's it. Okay, so you see what do we do here? We use the formulas. So you need to know the formulas, if not it'll be too difficult. Right? We try one more. See the screen?
Yeah, I can see.
Alright, so can you tell me how to solve this question? I want to find what's the name given to this resistor?
Parallel.
Yeah, parallel. See, it's called 1
It's
mark.
just parallel.
Yeah, it's parallel.
Like no need write anything else, but just
Yeah,
parallel.
it's just this is parallel, ma.
Oh, okay.
Okay, what's the combined resistance? You tell me, I write.
What? 1/3
Mm-hmm.
plus 1/6
Equals to
3/6.
3 over 6, 2 lah. 2 over 6.
2/6.
Plus 1 over 6 equal to
3/6.
3 over 6. Now this is 1 over RT. So is this the final answer?
Huh?
Is this the final answer, 3 over 6?
No.
No, what should be the final answer?
1 divided by 3/6.
1
Yeah.
Okay, so what do I get? What's the final answer?
Wait, let me calculate.
Actually, you see, are you there?
Answer is 2.
2, very good. Alright, so it's 2 ohm, that's correct. So we go on to the next one. What is the potential difference across the resistors? Okay, so what is the meaning of PD?
Voltage.
Voltage. So how to find volts? We got 6A.
Resistance. Ampere times resistance.
Yeah, because V equals to IR, right?
Yeah.
So I is 6, right? Then
Yeah.
R is
2.
2 equals to
Answer is 12.
12 volt. So that's correct. Okay? So actually not too bad, you know how to do. It's not too difficult. Okay? Yeah, so let me see. So what happens is that there's just different combinations of voltage and all this stuff. Alright, and then we actually have one more part that is practical electricity. Now in practical electricity you need to calculate the there's more calculations. This is where you need to use the EPT part, the energy. You need to find energy, and of course
Then what about the theory?
The theory is all the EPTIVIR. This one, practical. Oops. This chapter, right, is the EPT. Energy equal power times time. And if you need to find kWh equals to kW times h. The
kW is
kWh.
kilowatts, right?
Yeah, calculation for cost of electrical usage. This chapter. That's what this chapter is about.
Yeah.
Alright, so basically you need to use the top triangle for this part. Alright, for most of the question. Of course, the 3-pin plug. You know the 3-pin plug? You know the 3-pin?
Huh?
Do you know the 3-pin plug?
The 3 what?
3-pin plug. This one is the neutral.
Oh, yeah.
Then this one is the earth. And this one is the live, right? Then live connect to fuse.
Wait, that's not another pole, right?
That's not another one. Fuse.
The fuse is not another hole, right?
No, it's not. It's just a fuse. So the live is connected to the fuse. And you need to know the color. Like color of neutral is blue. life is red or brown. Okay, and earth is green or yellow. Green and yellow. The color. Right, so there's more to talk about for this part. Okay, can? Okay, so sorry, I gotta go right now, so I don't have time to finish the rest. But usually, what I do is that I would like to go through every single one of them, and you realize that a lot of them are repeated. Like you see all this stuff, they are repeated. So if you know how to do them, you look at the test series, you'll be fine. Okay, you just repeat a couple of times. Most of the time, it's pretty okay. Alright?